So you can see that these split connections down here are indeed 4-wire if they're split. So let's turn this on and press calibrate. Okay. Well, press and hold for 2 seconds. Okay, it wants an open. I'm not going to connect any leads to it, and so now it's open. It'll take 30 seconds for this to find out that the characteristics of the lead is almost nothing. So it passed. Procedure is to push it again, and it'll ask for a short. Well, I'm not going to use any test leads. I'm just going to stick a short in here. See how I did that? That's a short. And we're going to make this reading now with a 4-wire connection. Where the 4-wire connection turns into a 2-wire connection just below this yellow sheet. So now the meter knows the characteristics of the lead, which is no lead. Okay, so go back to the automatic LCR measurement range. I'll plug in a 10 ohm resistor. And the meter automatically sees it's a 10 ohm resistor. Using a 4-wire measurement to just below the yellow sheet, turning into a 2-wire measurement here. Okay? We have to remember, where does it turn from 4 to 2 wires? In order to get a set of leads that carry our 4 wires out into the world, we have to use an adapter that plugs in at least to these 2 and separates them into 4. Now, this company sells such an adapter. They sell a couple of them, really. Here's one. Now, where's the 4 leads? So these are dummies to prohibit you from sticking something in here while using the 4-lead adapter. Well, I say 4 leads, but where are they? Well, let's take a look at what we really have here. Here you can see that inside this cable are 2 wires, a red and a white. You see them buried down there? And inside this cable are another, you just barely see it, but there's a red wire there and a white wire. So we have 4 wires coming as far as this. That is to say, 4 wires. A red, a white, a red and white, 4 wires. They become, okay, the 4-wire measurement becomes At this point, back here's 4 wires, and up here's 2 wires. 4 wires, 2 wires. That's the transition point from a 4-wire to a 2-wire measurement. So we'll take a look inside. Now what we've got is two conductor cables entering here. Each one has a red and white. And note that the cable is shielded. Both of them are shielded. That shield is what differentiates a lead suitable for DC measurements and a lead suitable for RF measurements. So anytime we measure L or C, it behooves us to use shielded or guarded cable. Now let's look at this. This shield's connected here to this trace that zigs down here to here, which is where the other shield's connected. And they both go to this, which is also this. It's a guard connection. So this circuit board is what plugs into the guard circuit. The red and white wires, these two, are connected either side of this. And these red and white wires, one over here, are connected one to this side and one to this side. That means this adapter brings the 4-wire capability of the meter out, 4 inches, whereupon it turns into a 2-wire connection. The meter also comes with this adapter. It's the same style plug-in. Take it apart and look at the wiring connections inside first. Here we have what looks exactly like the other one, except instead of a pair of red and white and a pair of red and white, we have 4 wires, yellow, black, red and white. And I believe you'll find that these 2 are shielded and these 2 are shielded. So there's, I believe, in this cable are 2 pairs of shielded wires. But again, it becomes 2-wire. Let's see where that happens. Well, I see a screw. Let's take a screw apart. Probably damage it. Oh, looky there. The red and white appear to be shielded. The red wire is connected to this trace. The white wire is connected to this trace. And essentially the same thing happens over here. I hope I didn't break off a pin. No. So it's 4 wires from the adapter itself to these little screws. And that's the point where the 4 wires, 2 and 2, are connected together. And so this is the point of demarcation right there. 4 wires here, 2 wires here. The idea of the 4-wire cable is to minimize the 2-wire connection. So if come clear to the end of the probe, converted to 2 wires. And they've got shielded cable the whole way. Pretty nicely made set of probes. The probes are secured only with 1 screw right here. And in this location, the plastic is sort of thickened to give the screw some material to screw into. So I'll put this back together, hopefully. So when we're using AC for exciting the circuit, we do that to measure capacitance and inductance. We want to make the conversion from 2 to 4 wire as close to the device under test. We want to use shielded or guarded wire. But it doesn't hurt if the excitation and the measurement are contained in the same shield. So 4 wires paired and shielded individually, or two pair wires shielded. Here are two pair wires. So the 2 important things are get the 4-wire system as close to electrically the device under test as possible. And if you're measuring L or C, or anytime you're exciting the circuit with RF, use shielded cable or guarded cable.